To our first video lesson. So today we're talking about optimizing volume and surface area, and we're just going to be focusing on rectangular prisms. Okay. So our learning goals today is to find the maximum volume and minimum surface area with some constraints. Okay. So just like how our optimal area was a square, that can kind of be translated to our 3D rectangular prisms. So among all rectangular prisms with given surface area, so that just means for all rectangular prisms, let me get my pen ready to go. Given surface area, a cube has the maximum volume. Okay. So for all rectangular prisms with a given volume, same idea. A cube, whoa, we're not working. A cube has the minimum surface area. Okay. So our cube is what we usually want to find when it talks about maximum volume, minimum surface area. If there are constraints, it may not be possible to form a cube. This is not cooperating. Okay. The maximum volume and minimum surface area occurs when the dimensions, let's see if it's not going to let me do it. Okay, good. When the dimensions are as close as possible. Oh, can't even spell close today. Still having a Monday. Are as close as possible. So if for some reason, let's say a constraint is that the dimensions have to be whole numbers. So if you can't get a perfect cube, then just make sure that your dimensions are as close as possible to a cube. If one or more of the sides of an object are missing or bordered by a wall or other physical barrier, the optimal rectangular prism it just depends, right? So it might be different. So it depends on the situation. But you can use diagrams and calculate to find the dimensions of the optimal rectangular prism. Okay. So if one of the sides are missing, you have to do calculations, draw some pictures, and figure out how you can get those dimensions. So rectangular prism, so the volume for rectangular prism is length times width times height. And the surface area is going to be 2 of side 1 plus 2 of side 2 plus 2 of side 3. Okay, so that's the area for each. So I'm actually going to change those labels. Surface area equals 2 of A1. There we go, it's better. 2 of A2 plus 2 of A3. With a cube, it simplifies a little bit because here, length times width times height. For a cube, all of those will be the same. So it'll just be length cubed. And then for surface area, because it'll be a cube, all the sides will be the same. It'll just be 6 times the length squared. Okay. So example 1, so each of these boxes down here has the same volume of 4,000 centimeters cubed. So calculate the surface area of each box and include the bottom of each box. Then list them in order from greatest to least surface area. What I want you to kind of think about and figure out is which is the best shape, the optimum shape, so the minimum surface area given the volume. Okay. So how do we calculate surface area? So we'll do one calculation together. So surface area, like I said, is 2 of A1 plus 2 A2 plus 2. Well, that's a weird 2. There we go. Okay. So let's look at our dimensions and our sides. Okay. So for A1, we can call this A1. hard to get perspective on this. The back one would be A2, and the side here would be A3. So the bottom would be 2. And our dimensions here would be 20 by 20. For A2, it would be 2 times, so 20. Nope, that is incorrect. A1 is the bottom here, so 20 by 10. There we go. A2 is this side here, so that'll be 20 by 20. And then A3 is this side, so that'll be 20 by 10. Okay. So when you do all of that, you should get 1,600 centimeters squared. But as always, check my answers because I obviously make mistakes sometimes. Okay. So that's 1,600 cubic centimeters. If you were to go through and calculate this one, you should get 1,536.9 centimeters squared. Okay. And this one. So surface area here should be 1,800 centimeters squared. Okay. So we want to look at which one was least surface area and tying this to more real world kind of situations. Least surface area means the least amount of cardboard if we're building a box. Or if we are building like a metal crate, we want the most volume for the least amount of surface area because surface area is the material that we'd be building this box out of. Okay, so that's why it's actually applicable to real life. So therefore, let's say prism B is the most optimum prism. And check out the types of rectangular prisms we have here. The long and skinny one. We have kind of a cube one. Another kind of cube one. So we know the cube is going to be our winner, right? We know a square is the best area first, like area. And we know a cube is the most optimum for surface area and volume. But what's the difference between this one and this one? So just take a think. Okay. Because this cube, the dimensions are closer together, that makes it more cube-like, right? Like we said before, the maximum volume or minimum surface area occurs when the dimensions are as close as possible. So aside with rectangular prism B here, they are as close as possible to each other in relation to other rectangular prisms. So that's why it's the most optimum prism. Okay. So for any rectangular prism with a given volume, the cube will have the minimum surface area, and for surface area, a cube will have the maximum volume. So once again, just reiterating that, a cube is the goal for minimum surface area and maximum volume. If we can't have a cube for some reason, as close as numbers, to get those dimensions as close as possible, that's the goal. So example 2, you are the owner of a moving company. You want to design a box that has a maximum volume. What are the dimensions of the box if you want to have a box with 2 cubic meters? Okay. So there's no constraints on it. We're allowed to use decimal numbers. Remember, so our goal is the cube. So we go back here. Our formula for volume of a cube is V equals L cubed. We know our volume. That's our goal. So 2 equals L cubed. And then we just take the third root of 2. Okay. So if you grab your calculator, you should see on it somewhere. Just let me get that turned around. So on your calculator, okay, it's usually a button that looks like this. Okay. So you're going to do 3 and then that button and then 2. So it's just taking the third root. So we'll get about 1.3 equals our length. Okay. So once again, it is 3, this x root button, and then 2. And you should get 1.3. Okay. So remember we needed the therefore statement. Therefore, the dimensions of the box are 1.3, 1.3 times 1.3. Okay. So remember, cube is the goal. Especially if there's no constraints on us, that means you set. Okay. So remember, that is it for today. So Nugget we have on Wednesday. So I'll be on sections 2.3 to tomorrow. There are the practice questions. Make sure you actually do them, okay? Because there are some good questions in there that could be on the test or the Nugget quiz. Okay? So if you have any questions, talk to people around you, work hard today, do me proud. I'll be back tomorrow, and we can look at these practice questions if you have any issues. And I will be checking homework tomorrow, so you do have tons of time in class. Get it done. I'll see you tomorrow.